Hey, everybody. Exactly. Hey, everybody. We're going to get the ops track started. So if you're going to get a seat in here, please get a seat in here. If you're going to talk, I don't know where we're going to stick you. But yeah, so hi, my name is Ryan Moon. This is the ops track. The agenda I posted earlier is partially correct, apparently. So if you have a conflict after these guys talk, come up and see me. I think the first 3 talks are absolutely correct. So if your name was not in the first 3 talks and you're supposed to talk, come see me as soon as I stop talking. Other than that, we're going to try and go fast. I suspect we have to slip 1 extra talk in today, so I'm going to be trying to mush some people along if it starts to drag. I do want to underline something that Gotti said earlier. This is a community conference. This is not like I'm not someone special. I just know Gotti, and he was like, "Hey, can you do this?" And I'm doing this. So there's a lot of stuff that we're going to be going over, and everyone's going to be talking about. If you have a question, I would encourage you to just start talking. Wait for a pause. Don't be like right in their face. But for the most part, this is an interactive conference. You guys are not just drones sitting in a movie theater. You actually are people who are very smart and do your jobs and have a different perspective than me or anybody who's talking. And so I would encourage you to go against your base nature and speak up when you hear something. Other than that, this is Justin Borland, my coworker, who's a fantastic person. That's the last time I'll be complimentary towards him today. And this is Greg Olmstead, who is an awesome person. I'll be complimentary to him for the rest of his life. They're going to be presenting on Phoenix, which you guys will find out here in a second, is a project I love, and I'm so happy that they're first because this is fantastic. Take it away. It's great.
Thanks, Ryan. Glad you know where to hitch your horse to. Okay, so I'm Greg, and this is Justin, as Ryan introduced, and we're here to talk about Phoenix. If anybody has questions during the presentation, rather than shout them out, because we're trying to sort of keep to a timeline, there's a link here at the top. Feel free to submit your question. It'll come up on our fancy screen over here, and then we'll be able to answer it, or hold it to the end. So just a little bit of intro first. I'm Greg. I'm a software engineer. I'm maybe one of the few people in the room that isn't working in the security industry actively. I work at Thomson Reuters. I build trading software, things of that nature. I used to work at Atomic Energy of Canada, building software for nuclear reactors. I worked at Citi, stuff like that. And so I'm here today as the engineering side of Spark IT.
Perfect. So my name's Justin Borland. Started out my career with Greg at Atomic Energy. Both our parents actually worked at AECL for about 30 years. So we've known each other since we were about 12 or 13. And when we both got employed at Atomic Energy, we decided we'd want to start a company. And so we started Spark IT Solutions. Within, I think, about 6 months, we had a contract with RSA building a logging system. We didn't build Envision or anything related to that, but we had a logging system that front-ended that. Worked at BlackBerry for 3.5 years. I worked at Equifax. I was the technical lead for the Cyber Threat Center there. I ran countermeasures. I built the packet capture system that found the incident from 2017. My team, worked that to completion, and I had the privilege of being interviewed by the private subcommittee for investigations for the U.S. Congress. So fun stuff. And now I work at Barclays with Ryan Moon, as he said. So let's get right into it.
All right. So for any of you who were here at ACoD last year, you saw our original talk on Phoenix when it was in its infancy. But just to give you a little bit of a recap, Phoenix is a standalone open source malware analysis appliance. We integrate Cuckoo, MISP, Moloch, and several other goodies in one box and make it really easy for anybody to go and throw it on a machine and have a fully fledged, malware appliance in, an hour after you go get a coffee. We put this out free open source. And the idea is that you can detonate, analyze, report on malware activity, and create threat controls in a very tight OODA loop. We've made a significant amount of improvements and fixes on top of all the original core components, especially Cuckoo. So Phoenix is something that takes all of these components and makes them much more readily usable by your average security researcher. This is our architecture. Justin, you want to cover it all?
So input feeds, this can be anything from packet capture stuff where you're scraping files off the wire to reversing labs hunting, virus total hunting, anything like that, manual submissions. That goes into the Cuckoo system, goes through Cuckoo API, then through Cuckoo D, walks down that stack right there. And underneath the hood, you've got a bunch of databases within Docker containers that run all of this stuff. from the right side here, you've got the Cuckoo Web and Moloch. That's sort of where your analysts are going to be interacting with a lot of the data that you're generating. And that's sort of, at the bottom there, it says 33 open VPNs. The only limitation we have, I think, is under 252. So as long as you can keep your VPN count under 252, you should be able to use that many VPNs without any problem.
So, I mean, just to give you a little bit of information on some of the more core components, ACoD is our analysis engine. That's what's feeding the virtual machines your bad stuff when you submit it through Cuckoo Web or through the Cuckoo API. And then CuckooP is taking the results of that, the memory dumps, all of that kind of stuff, and running them through all of the various processing modules that we have integrated with it, including MISP, Elasticsearch reporting, all of that kind of stuff. Some of the stuff that's not pictured here is hunting. We have Yara and Suricata hunting built in, which is all Dockerized. We'll talk about that a little bit later in the presentation. But if you have any architecture questions, please feel free to reach out to us. Okay, yeah.
Cool. So one of the things we really focused on the last year was the Yara and Suricata hunting, wanting to be able to use this data a little bit easier, regression test your controls before you go and put them in production, that kind of thing. The advanced searching, since last year, we spent a bunch of time trying to index the crap out of everything in Mongo that we could, make it easy to pull data out in a timely manner. Added a bunch of pivoting to a bunch of the different components within Phoenix. So quicker pivots to things like CyberChef, Moloch, MISP. The dashboard layout is all done. Does it integrate with case management solutions like that? Well, the good thing is it's open source, so it can do anything that you put your mind to, right? It's open source. Does it do that now? No. But could you integrate? Yeah, I mean, I don't see why you couldn't.
We have a Jira for that.
Yeah, well, yeah, and we're actively doing development on this. If there's stuff that you guys actually use this for and you want us to change it, or there's a feature you want added, by all means, let us know. So, easy bulk submission. So that was one of the other things we wanted to do. We get so many of those PDFs with hashes and stuff at the bottom, and I wanted to be able to just copy that and throw it straight into Phoenix and have it do the heavy lifting, and then basically at the end of that, show me the green check marks if I have controls for it, or if I don't, then don't show me the check marks. So that was kind of a really useful feature. Oh, this is fun. Okay, so Christmas, fun story time. I drove up to Canada for Christmas this year, and 6 days after I got there, I had a seg fault. I ran my main Phoenix system out of 192 gigs of RAM, and it died. It backflipped. And one of the things that we were doing, we were taking all these backups of the various components, the underlying databases, stuff like that. We didn't really practice restoring as well as maybe we could have, should have. So over Christmas, that was our time to make this a little bit more robust and start doing things to, you know, if you guys have catastrophic failures, back your database up every night, and then you've got, you know, the data that you can restore from that. So we had a sort of a backup and recovery under duress over Christmas, and as a result of that, we've got backup scripts now. So live and you learn, I guess. MongoDB, MySQL, Elasticsearch, MISP, configs. I forgot all of the reverse proxy files, the HT password files. So over Christmas, I was hand making like, you know, massive HT password files to get back to where we were. The compression, so I don't know if a lot of folks use this, but Cuckoo has the ability to generate IDAPRO PI files out of like unpacked samples, and they're huge. They're really, really big. And so one of the things that we wanted to do was turn that on and use them, but compress the crap out of it so that it wouldn't fill up your whole system. And as a result of that, we ended up going through and compressed basically anything that we could compress. So within Cuckoo, they have reports, they've got files that get dropped. Anything that we wanted to scan with either Suricata or Yara, we didn't compress. And then anything else that was just downloaded or used later, we compressed a lot of that, and we're able to get a massive storage savings to basically, our average sample's anywhere between 20 megs and 50 megs now, and it was upwards of 300 megs before. So certainly useful. Who's up next?
How many samples can Phoenix handle concurrently is the next question that we got. We will be covering this in a later slide, so I'm going to keep that off for now. Mac, okay, next question here. Mac OS support in Bade Cuckoo is kind of broken. Official support was taken out. It's possible to hack it. Have you thought about Mac? We haven't really thought too much about Mac. That is something that we'd like to look into. So whoever did ask that question, please come and see us, and we'd love to pick your brain about that a little bit at the end of the talk. Okay, so some of the changes that we've made since the last time. TLP. TLP was a really central core component of Phoenix. We figured that basically if you don't have the ability to limit who gets to see the results of your analysis and your processing, then there's absolutely no point in having Phoenix. So TLP was basically introduced to all of the components that didn't support it before. Cuckoo, Moloch, all of these things didn't have any capability for proper role-based access, so we've implemented that. We originally used to use Mongo for this. We switched to MySQL to do that because Mongo, unfortunately, would fall over when you're dealing with hundreds of thousands of records. We also rewrote the API to use GUnicorn. The Cuckoo API, even in its current implementation, is single-threaded, and it completely falls over if you have something hanging up the main thread. So it becomes totally useless to actually try and submit any large volume of files. We've rewritten the processing module significantly for MISP. The MISP module was totally unusable in the original Cuckoo. It didn't work at all. We've rewritten several of the modules, but that one was the one that we did most heavily. We also rewrote it to be able to leverage different media better if you want to do things like processing in memory completely. There are challenges to that aren't immediately obvious until you actually start doing it. So we've made a lot of changes to make the ability to generate your memory slice and do all of your stuff in memory and make your processing way faster. And we'll talk about how that affects our run rate a little later in the presentation. The auto tagging workflow. This is something that really helps with the end-to-end processing and analysis in Phoenix. Being able to take something from ingestion at the web or API side and go all the way through to automatically tagged MISP events, where you can basically say, okay, I know that these types of processes, these types of criteria basically mean this. I want it to tag it with this, and then those tags get brought back into the dashboard, and we'll talk about that a little bit later as well. Some more of these changes. We rewrote a huge amount of the web UI. The Cuckoo web UI, while somewhat useful, was also very limited when you started getting into large volumes of data. The recents page had absolutely no information. The search page was basically just doing an Elasticsearch dump and didn't really give you anything useful. So we've basically rewritten the recents page to be your main source of information about all of the stuff that you have in Cuckoo. We'll show you some screenshots of that. We brought all the command line, all the HTTP stuff up to the surface and make it able so that you can both client-side and server-side search it. We have the advanced search for more deep searching, where you want to search across multiple really fine-grained observables. So we have the ability to do that. The web API was completely unusable on mobile, so anybody who wanted to use their phone or tablet to, juice malware was not able to do so without, real pain. Much better Mongo indexing. Originally, there basically wasn't any, and so the ability to do any real kind of searching or even a real kind of data retrieval at any scale was just not there. And also an update path. So Cuckoo's gotten better at this lately with the new 2.0 releases, but in the earlier releases, Cuckoo was very, very difficult to update. It was a very manual process. We've automated that. You want to talk about MISP?
Sure.
Talk about MISP.
Let's talk about MISP. So originally, as Greg said, the MISP module wasn't really usable. Wasn't really doing what we wanted it to do. First stab at that, Corson basically laughed me out of the room and said, you need to start using relationships. We used relationships after that. Now we have things like mitigates, different relationships where you're able to package up not just these indicators of compromise, but the controls that would have otherwise saved you had you had them in your environment. So again, one of the main reasons behind this was to create that OODA loop to say, okay, I've got malware. Do I have a Yara rule for it? Do I have a network signature for it? Yes, no. If no, I have work to do, right? So that has been very much streamlined. The MISP as well, pushing Suricata and Yara, it makes it incredibly easy to do things like tagging. So one of the things that we use Suricata and Yara and MISP for is if a certain rule fires, you can then go and tag that rule with MISP tags. And so what you can do then is say, okay, I've got stage 2+ rules that fire every time Emotet sends a certain cookie. Well, now you can start auto tagging all the detonations that you have that went stage 2+ because you know that it tripped a rule that only fires when you've got C2 happening at stage 2+, right? So now you can use these Suricata rules and Yara rules to start tagging within MISP. In addition to that, if there are things like, let's say, command line, pass, arguments, whatever, anything in the command line, you can apply a regex to that and then use that match to auto tag as well. So all those observables, as long as you can put a regex to match it, you can then go and programmatically punt that over to MISP. So event graphs, awesome. I'm a sucker for visualizations and MISP event graphs, especially when you have data with relationships. It makes for really cool pictures. Yeah, Yara rules tagging, we went over this. Heavy integration, REST dashboard. Let's see some screenshots pretty soon, I think. Yeah.
Let's answer a couple more questions.
Oh, okay.
This one's for you. Most of the time, Sync and Cuckoo is maintaining VMs. How do we deal with it?
So played around a lot with Flare, as well as a tool that David Heisey wrote, which prepares VMs for anti arms races. I would start there. And then after that, it becomes daily work done daily, weekly work done weekly. When you see people avoiding your configurations within your system, then it's time to evolve. Sadly, this doesn't do everything for you, right? It will show you when you need to do work and collect enough data so that you can deduce this stuff, but you still have to work, and that's part of the reason why we get paid what we get paid, right? So.
Next question. Are you using Cuckoo 2 or the million branches of Cuckoo 1?
Well, that's a loaded question too. So technically we're using 2.0x legacy.
Dev.
Right. So we got on the 2.x train 3 weeks before they migrated everything to Python. So, to the Python module.
Yeah.
So it's in our Jira.
The migration path to Cuckoo 2 from Cuckoo 1 is a mount. Truly a mount.
If anybody likes coding in Python, wants to help us out, by all means, reach out to us. Anything else?
There was the highest question. Go on.
Okay.
TLDR.
TLDR, what about? Oh, here we go. So TLDR was basically, we wanted it to on-demand boil this data for you and give you a nice pretty JSON package that had all the stuff that you really cared about. Things like DNS that was resolved, command line arguments, C2, and then everything in TLDR uses the underlying whitelists within the data whitelist folder within Cuckoo. So that becomes another daily work done daily, weekly work done weekly, making sure that your CDNs you're not sending into MISP in a garbage in, garbage out type situation.
So a really big ask from last year was, can you make this easier for us to deploy onto a system? Now, Phoenix was already something that would do a lot of work for you. It would take all of these different modules like processing and analysis and give you nice init.d scripts to run them automatically at startup and all of that great stuff. But there was still a lot of manual steps to actually getting the system running, and there was a lot of things that you could do wrong. So we thought, okay, how do we make this so that anybody who isn't familiar with Phoenix already can just go ahead and start? So we created the easy button. Basically, the easy button is a very large bash script, which takes a lot of the variables that you would originally have to put in yourself and automates it for you. At the top of the easy button is all of the configuration that you need to set, basically your networking stack, the way you want your network to look behind the scenes, i.e. your Docker network, and credentials and things like that. And then once you hit go, you can go get a coffee. An hour later, you've got a fully set up Phoenix system. All of the user and group in like creation, where in MISP it's sharing groups, in Cuckoo it's Django administration groups, all of that kind of stuff. All of that has tools built into Phoenix to help you administer those, so you don't have to go and manually create all this stuff or manually create all these users. Especially when you're trying to onboard 1,000 users, you can do that very easily now with our script. And all of that is integrated with TLP as well. So as soon as you create these users in these systems using this one easy script, you're basically ready to go and start punching miscreants. So Docker was one of the big things that we thought was going to be, a big help for us because we have a lot of different components that fit together to make this a truly fully fledged system. We didn't want to just be having the stuff that actually juices the malware. We wanted stuff to be able to enable you to, see your logging, see what your stats are like, keep track of how the system is performing, all of that stuff. And we wanted that all out of the box without any extra clicks. So we've integrated various things like Grafana and Kibana on top of Elasticsearch, net data, kind of stuff to sort of give you a way of monitoring your system, as well as the MISP, MongoDB, all of the hunting, basically everything is running in a Docker container except for Cuckoo itself. And the only reason Cuckoo isn't right now is because of the VMs. We're working on that. That's something we'd love to get into Docker as well. And then basically you can scale this out across Kubernetes like stink. So our dashboard, the Cuckoo dashboard, or the Phoenix dashboard, I should say, is much improved over the original Cuckoo dashboard. We now have MISP tags brought into the front screen where you can see all of the tags that you have across MISP, all the events that you've matched, so you can see what kind of real detonations and what kind of real detections you're making. Moloch quick link searches, so you can actually see a quick view of some of the canned reports that we've provided in Moloch, and some stats to sort of keep an eye on how your system is performing, what your run rate is, your reporting, stuff like that. Our Grafana dashboard is, we have one for monitoring MongoDB because MongoDB needs a lot of babysitting. This will get you sort of keep an eye on how Mongo's performing. And also one for Elasticsearch, a little more detailed. This is going to give you a really good, ability to view how well Elasticsearch is performing and if it's, doing what you're expecting it to do. Kibana, we have some canned reports to help you understand who's talking to your system. This one, for instance, is looking at the IP tables log output, and all of the logs from all of the Docker containers, from IP tables, from Linux, all of that is being farmed up through syslog to Elasticsearch and Kibana automatically. So you don't have to do anything there. All of your logs will appear in Kibana. Like I said, this is IP tables, so you can sort of get an idea of who's hitting it, when they're hitting it, and what IPs. Yeah, sure.
So for the logging portion, if anybody here is using Docker containers and they aren't centralizing all of their logs for that, check out the easy button, check out what we've done there. It makes it extremely straightforward to take all your Docker containers and shunt that all over to Elasticsearch, get it all indexed, make it searchable, make it usable.
Yep. And one more canned report that we like is the web user stats. Like, when you're actually giving the system to a bunch of people to use, you want to be able to see who's using it, when they're using it, what browsers they're using it from, what kind of responses they're getting, are they getting errors? Like, all of this stuff is available to you, and you can drill through it through Kibana. I mean, I'm sure most here are familiar with Kibana. This is just all out of the box, ready for you to go and manage your system.
Link Monitor. So Link Monitor came about out of necessity. We don't have too much details that we're going to be releasing right now, but essentially Link Monitor is a Dockerized system that will spin up OpenVPN clients and allow you to bind to those Docker containers to then go and download payloads. Now, the thing that sort of makes this really useful is that by even invoking this and using it, the first thing it does is go out to whatismyip.org, grab your outside global, and then when it goes and marches that path through the Docker container, the very first thing it does is double check that in the Docker container, it's not exposing the IP address that it had from the host system. So it takes that guesswork out of that OPSEC portion that you have when you want to go and programmatically download these implants, whatever you're talking about, right? So Link Monitor essentially, in its infancy, took the URL host feed, auto-submitted it to Phoenix, and one of the things that we're heavily focused on is then monitoring the up-down status and payload status of those stage 2+ resources. So what we care about is knowing when that stuff changes, and if we have a control for it, all of a sudden it goes into that OODA loop again. Oh, look, more tradecraft. Now it's time to analyze the tradecraft. Well, has it changed? Have our controls changed? And so on and so forth. So this basically gives us a nice streamlined mechanism to monitor that nefarious stuff that we really otherwise we need to be careful about, right? So the number one thing was make sure you don't lose your OPSEC, and that's why we built that. So API fingerprinting is another is another useful tool that we have. So one of the situations we came across was that certain malware didn't like to detonate in certain ways, and the checks that they performed were fairly static. And what they were doing is using, certain libraries within the Windows API. And what we did, can you go to the next page? So what we did here was we created a mechanism so that you can create these API fingerprints that give you high watermark, low watermark in terms of the number of uses per API. So now you can build a dynamic analysis fingerprint for your malware. Does this work for everything? No, it doesn't work for everything. But in certain situations where you have a flavor of malware that likes to bomb out in a certain way or doesn't like to behave a certain way in a virtual machine, the vast majority of the time when that happens, that check that they do is a static check. And so even if you don't get the malware to detonate, in many cases, you can understand what type of malware it is because it's using the same avoidance routines as everything else. In addition to that, if you have other, like we were using this to track PowerShell payloads, because they would go and evolve and ebb and flow, and so PowLoad and stuff like that, we were looking at the counts for this to basically give us that dynamic fingerprint to match up against all our data.
So we're running out of time here, so we're going to quickly gloss over some stuff. So submission usage limits, big thing in large enterprise deployments. You don't want somebody basically monopolizing your entire Cuckoo deployment, especially if you're not running on really big hardware. So we added the ability to restrict, people to a certain number of submissions per day. Default is 25. Go on.
Can I go through the media stuff because we only have one?
Yeah, go ahead.
Okay, so we're gonna gloss through this. Mobile friendly, it's super beast mode. It's double full beast mode actually. Hunting, this is stuff that you guys probably want to see.
Come see us.
Yeah, come see us. Yara hunting, you can see stuff within memory, within the files. It'll let you download all of your hits like that. Performance improvements. Okay, so this took a lot of work. In addition to all this, and you guys want to see pretty graphs. So this is what it looks like when you're doing processing on spinning disks, RAID 5. You'll see the pinkish hue down there is your I/O. And that's going to be your main limitation if you're using, spinning disks for this stuff. So what we did was we made the ability to change your processing media. So now you can specify whatever you want. And for us, we use RAM disk to process all of the memory and everything. And the reason we do that is because now that we have high watermark, low watermark processing, we can say, okay, my tempfs is this size. X number of mem dumps fit in that processing. Therefore, my high watermark is Y. And so that way you can guarantee that all of your data will live in memory until it's processed. Whereas previously, because processing and generating the data were completely decoupled, you would end up in a situation where you have 10 pounds of shit in a 5-pound bag perpetually. And when you do that, there's no way to catch up. And so what we built in the processing, the loop was that high watermark, low watermark. And one of the things that we get to see here, these are the different states. So running, pending, reported, blah, blah, blah. And what you can see, this trend down here, we did some analysis on when we changed the media. So this is spinning disk. The rise over run is your processing. So you can see stuff's going from pending into reported, and that's good. And what we found was we were getting 0.8 per detonations per minute on 4-disk spinning RAID 5, and when we moved to memory, we were almost double that. So we got 1.466 detonations per second on this, but that was only with 32 gig RAM disk. If you are able to, let's say, take 128 gigs and a bunch of cores and throw that, now all of a sudden your processing is going to go N, where N is, you can divide this into whatever you're actually going to use. So 14 on a box with spinning disks, you're talking around 1,000, maybe 1,200 samples a day on a box that I was 7 years old and I spent $400 on. And on the bigger box that had 72 gigs of RAM, we were able to get around 1,500 a little more than 1,500 detonations per day on a box that cost $1,000.
All right, thanks everybody. Does anybody have any more questions? All right, cool. Come see us. We'd love to talk about Phoenix all the time. Thanks a lot. Have a good day.